Hi, this is an interesting problem on proof by contradiction. It asks you to prove that square root 3 is irrational. So remember, when you're trying to do proof by contradiction, you assume the opposite of what you are supposed to prove, show that leads to a contradiction, and therefore conclude that your original assumption is false. So you start by assuming that square root 3 is rational. It can be written as a over b, where a and b are integers, and they have no common factors. And then you square both sides and get 3 is equal to a squared over b squared. Okay, then you think for a while and you get to statement 1, a squared is 3b squared. And the crux argument is that if a squared is divisible by 3, then a is divisible by 3. And therefore, b has a factor of 3, a has a factor of 3, and hence you have a contradiction because a and b have common factors. But this crux argument is not so straightforward. There's more to it. So from a squared equal to 3b squared, you get a equals square root 3b. And they tell you that a is an integer. So there are two cases. At the beginning, you have no idea whether square root 3 is irrational or rational. It's what you're supposed to prove. So if square root 3 is rational, which is what you're assuming, then you just get a equals to a, and you cannot solve it. Whereas if square root 3 is irrational, then for a to be an integer, b has to be square root 3c, and you get a equal 3c, and hence 3 is a factor of a. And this is the problem. In order to conclude that 3 is a factor of a, you have to assume that square root 3 is irrational. So the argument is circular. You're getting this result because you're assuming it halfway. And so I think there's a problem with this statement, a is divisible by 3. It's an interesting problem. I hope someone can explain it to me. Thanks.